So hello everyone. In this session, I'll be explaining a simple code which will perform string reversal. What do you mean by string reversal? Let us take the string that we have considered here. Okay, that is hello ARM7. Once this particular code is executed, the result we are expecting is 7 M R A O L L E H. Okay, so this is the result we are expecting from this particular code. Fine. Now let's see and understand how exactly it works. The very first thing we notice here is the assembler directive area. Okay, so the purpose of area is to define a section of memory to store all this information. Okay, and string reverse is the name I'm giving to this particular section of memory, and code is written here to inform that all the information stored here is nothing but actual instructions and not data. Okay, then what we have is read only. This is because we don't want any modification to happen to this particular code during runtime. Entry is an assembler directive which indicates where exactly execution should start. The very first label that we find after the entry assembler directive is the location where the execution starts. The very first instruction we notice is a pseudo instruction. What this will do is it will load the address associated with these labels ESRC and DST and store them in the registers R0 and R1. Now let's see what are these addresses. If you notice here, source is nothing but a label which exists in read-only section, and then we have written something called DCB, which is define constant byte. The reason we have used DCB is because when it comes to ARM, it stores string as array of ASCII bytes. That is, if you check the memory after storing this in the memory, if you check what values are there in the memory, those will be nothing but ASCII values of these letters, each one of them occupying 1 byte or one location of the memory. So next what we notice is (0) here. That is because we are considering null terminated string. This is a very common practice to indicate the end of the string. Align here ensures that any memory alignment issues doesn't occur because of the usage of the DCB here. Then what we see is assembler directive, that is nothing but area. This performs the same task, that is it will define a section of memory, okay, with the name string reverse data. But if you notice here, one of the property or attribute of this particular assembler directive is data, which informs the assembler that in this particular section of memory, we are storing data, not instructions. Read write because we should be able to modify this particular section of memory. At the end of this particular code, our purpose is to store the reversed string into this particular section of memory. That's why it should be read write. DST is the label appearing in this particular section of memory. Space is nothing but an assembler directive which reserves uninitialized 20 here represents 20 bytes of memory, and end is a assembly directive which indicates the end of source file. So if you notice here, as I already informed, R0, R1 will hold the address associated with these labels. R0 is a pointer to the label source, okay, which means if you consider this particular string, R0 will be holding the address of the very first character. The address of R0 is now stored in register R2 also. Next we have the label find end. Under the label find end, the task that happens is in the memory you will see their concerned ASCII values. Okay, for example, caps H ASCII value is 48. Okay, so this particular value will be copied to register R3. Why? Because R2 will be pointing at the location where this particular letter or this particular character exists. When you use a square bracket here, immediately what it means is load the content, that is the ASCII of H, and place it in register R3. After that, R2 is incremented because of which it will start pointing to the next character. Okay, it is incremented by 1 because each of this character will occupy one location each in the memory. Okay, next what we see is we are checking if R3 value is actually 0. Why do we do that? Because the very last thing that we see here is 0. Okay, which indicates a null character. If currently R2 is pointing at this particular location, then the value extracted and placed in R3 will actually be 0. By performing this comparison, we are checking if we already reached the end of the string. If we did reach the end of string, then we are jumping to position, okay, to obtain the location of the very last character that is seen in this particular string. If that is not the case, we continue this particular loop. Okay, the purpose of this loop is only to find the position of the very last character that we see in the given string. Okay, we want R2 to be pointing to this particular character before we go ahead with any of the copying task. Okay, and what exactly happens in comparison? Subtraction happens. R3 minus 0, whatever result we obtain, result is discarded, but before discarding it, the CPSR conditional flags are updated. Okay, so what will happen if R3 is actually 0? Z will be set as 1. If Z is set as 1, branch if equal becomes true and we jump to position. If this particular condition is not true, then we'll branch back to this particular loop. Okay, that is what is happening here. Now let's consider that we have already reached the end of the string. This is how you will see ASCII of each value stored in the memory. One location assigned to each character. Okay, and 0 will be stored next to that to indicate the end of this particular string. If you consider here, okay, in which particular case will you get R3 as 0? R3 will be 0. Okay, if initially R2 is pointing here, this value is loaded to R3, but one thing if you notice here is that as soon as this loading task is done, R2 will be incremented, and at the end of this particular instruction, this is the position where R2 will be pointing. Okay, but what exactly we want? We want R2 to be pointing at this particular location, which represents the last character of this particular string. Okay, this is just the indication of the end of string, but this is actual last character of the string, and we want R2 to be pointing here. That's the reason we subtract R2 with 2, so that R2 will start pointing to this particular location, which was our aim of performing all this particular tasks. The address associated with DST label is a location where we want to store our final result. Correct? From this, we want to store this particular result at the location pointed by DST. And we already know R1 has the address associated with DST. Correct? So that is what you will see in this particular location. But before that, you will perform a comparison between R2 and R0. Why is this comparison required? See, this is the location where currently R2 will point after this step. Okay, and where will R0 be pointing at? R0 will be pointing over here. What we want to do is place this content here, place the next content here, and continue placing it until you find the very first character. How will you know you have already crossed the first character? By comparing the positions of register R0 and R2. Once you know you have already placed the value of H or ASCII value of H in the final destination, next thing that you have to do is place the null character. That is what happens here. So the first thing that we'll do here is we are trying to subtract R2 minus R0. Based on that, we'll get some result that will update the CPSR flag. Okay, and next thing that we will check is branch if less than. We are checking if R2 has already crossed all these locations and has it reached a location less than R0, that is this particular position. Okay, if that is the case, we'll jump to the label which will add null character to our final string. If that is not the case, we'll continue storing all the values. Now let's see how that happens. Okay, if destination is the label and this is the address associated with it, then R1 will be pointing at this particular location because of this particular instruction. Okay, what will happen at the end of this particular instruction? R2 content. Now R2 is pointing at 37, correct? Now this value will be stored in R3 and R3 content is then placed in location pointed by R1. So what is location pointed by R1? It is this location. So the value 37 or the ASCII value of 7 will be stored in the desired location. And then we are incrementing R1 so that R1 points to the next location, that is this particular location. Okay, so this is required for the next loop. Okay, and at the same time you can see R2 value being decremented. What does that do? R2 will now be pointing at this particular location which holds the ASCII value of M. Okay, and what will happen next? This content will be placed in R3 because of this particular step, and that content will again be placed in the location pointed by R1. Okay, so the ASCII of M will be placed here and we increment the value of R1 so that it can point at the next location. And this thing keeps continuing. Okay, until when will this continue? Until this particular comparison generates a result which indicates that R2 has reached this particular position. So as soon as it is less than R0, we jump here. So at the end of all this particular task, R1 will be pointing at this particular location. Okay, and if you notice here, the task that we actually do is store a value 0. R3 is stored as 0 and this content is stored in the location pointed by R1. Okay, so that actually finishes all our tasks, because of which we will jump to an infinite loop called stop be stop. Now let's see this happening. First we'll check if there are any errors. There are no errors, so we'll go ahead with debugging. So first let's note down what are the address associated with source and destination label. Okay, it's 44 and 4 all zeros. Now let's see what values are stored in the memory. Okay, so 48 is nothing but the ASCII associated with capital H, and these are nothing but ASCII associated with all other characters. 37 is the last character, 48 is the first character, 0 is our null character. Okay, so now let's just continue. First thing that happens is R2 gets the value of R0. Let's see that happening. Yes. So now we are loading the very first content pointed by R2 into register R3 and incrementing R2. So you can see here 48 is already loaded to R3, and when it comes to R2, that is incremented to this particular location. Okay, so we are comparing if R3 is actually 0. That is not the case. If you check the updated CPSR, we know that Z is 0, it's not 1, because of which this branch won't happen. And instead, this branch will happen, which continues the loop. Okay, so you can see all characters being loaded, okay, until you reach the end of the string. Okay, so we have already reached the last character, okay, but we are comparing R3 with 0, so it will go ahead and load this particular value into R3. Okay, but when this value is loaded into R3, R2 will already be pointing at this particular location. So even if this comparison is true that R3 holds 0, we are branching to position after checking that Z flag is actually equal to 1 due to this particular comparison to the label position. Okay, so there we subtract R2 so that it points at this location only. Okay, so now we come to this particular loop. Okay, we check if R2 has already loaded all the values and crossed the first character. That is not true. So this branch will not occur because R2 is not less than R0. Instead, it is ahead of R0. So what we do, we load the character pointed by R2, place it in R3, and then store it in the location pointed by R1. We'll see that yes, the first character is placed and R1 will be pointing to, if I show the numeric values, this is the location that will be pointed by R1. Okay, so now let's just change it back. Then what will happen, we'll branch back here. Okay, the comparison and the storing keeps happening, and you can see that happening here. Okay, so here I have placed my very last character. Now when I compare R2 and R0, since we have already placed the very first character, it means currently R2 is pointing at a location which is lower than the location pointed by R0. So because of which, what will be the output of this particular comparison? R2 will be clearly less than R0, because of which this branch will occur. If I change it to okay, so you can see that after the letter H, which is the very first character, value 0 will be stored. You can see that happening now. Yes? Okay. And this is nothing but an infinite loop. So that's all about reversing a string.